going to a wedding July 15th. There's nothing better than a summer and a wedding. Isn't it? Just think of the wonderful, the flowers and the music and the big white tent and of course the bride and groom. It's a wonderful image. Afterwards, he's going to celebrate with his siblings his father's 90th birthday. Whew, he's like on the bonus rounds, you get to that point. And he's thrilled with his father. Speaking of his father, he inherited a trunk, and not just any old trunk, a trunk full of rocks. Now we had a nice little chat about rocks, because I grew up loving rocks. I don't know what it is. And he's going to be speaking not only about rocks, but about early Minnesota history. And I mean early, like before us. Even before Bingham. A couple billion years ago, Jim. So he is going to speak 7 to 9 minutes. The objective is to take a dry material, aren't all rocks really dry, and make it interesting. The title of his speech, Bedrock. Ladies and gentlemen, please welcome Earl Netwal.
Thank you, Bob, fellow Toastmasters. How many of you are familiar with ancient Minnesota history? A few say so. We'll see. We'll see. How many of you are familiar with tectonic plates? Yeah, everybody seems to suggest so, but let me talk a little bit, if I may, about tectonic plates as a preamble to our ancient Minnesota history. Imagine an Easter egg. It's got a yolk in the middle, that's the core of the earth, and our earth has got an iron core. The weight of the egg is the mantle, the magma that's kind of in the middle of the earth, and that shell is the crust of the earth. Now imagine that you crack that egg, it's still there, and it's got a lot of different pieces. You know, maybe 7 or 8 or 9 kind of big pieces and some little crinkles here and there. That is, in essence, what the crust of the earth is a cracked egg, still whole. And the difference is that the eggshell can move on the earth. The crust of the earth can move around, and it does. All these different little, what they call plates, the little pieces of the eggshell, are plates, and they move. Some of them move horizontally or alongside each other. You might think of the San Andreas Fault as an area where the North American plate and the Pacific plate kind of go in opposite directions but alongside each other. Plates can also move toward each other and apart from each other. Now, how fast do these plates move? Well, it's interesting to know they move about as fast as your fingernails grow. Constantly, but everlastingly, they move, and the reasons for why they move is beyond the scope of this particular presentation. So just with that basic understanding that we are on a plate, Minnesota was originally on the North American Caton, which is the plate that we happen to be on. And about 2.7 billion years ago, another plate kind of snudged into the North American plate, and the strange thing happened. The two plates came together, and one of them was pushed under the other. And down here where my fingertips are, that's about 70 miles below the crust of the earth. So that's how far this oncoming plate went down. And it started down below on the fingertip level, started melting away. Now, when these plates came together, another thing happened. There's friction between the plates, and what that caused was that as it went down, a mountain grew. This first mountain was called the Allegheny Mountain Range, 2.7 billion years ago, and over the course of 700 million years, it just basically eroded away. To the north, there's still remnants, which are called the Pokegama quartzite. Some 300 feet deep patches of quartzite that are still remnants of that original mountain can be found in Minnesota. The plate that came in initially to form the mountains was actually older than any other rock we have in Minnesota. 3.5 billion year old rock, and now some of it is still exposed in the Minnesota Valley, at one time thought to be the oldest rock in the world. Subsequently, a few other older discoveries have been found elsewhere in the world, but very ancient rock available to be seen by walking right up to it in the Minnesota River Valley. About 2 billion years ago, after the 700 million years of this first mountain eroding away, a whole series of additional collisions occurred that grew the North American plate further and further and added to Minnesota. It's happened that apparently these were volcanic eruptions that occurred in the middle of wherever, and they formed islands, and these islands kept coming in, and there's a whole series that can be found in Minnesota where there's the remnants of all these arcs down below, and they can still be identified and found and mapped. Kind of an interesting process. The second series raised another mountain range called the Pokians. The Pokians also, over a course of about 600 million years, eroded away. In the north, there was what was called the Amica Basin. And part of that process of eroding away in the northern part of the Amica Basin was an iron forming element, which is now the Iron Range. And it helps explain where the iron came from and why it came and where it settled. Underneath, what this mountain is high, it creates pressure and it sinks down into the mantle. As it's tall, it goes lower. And magma, when it cools underground by 50 miles or so, it forms something we call granite. As the mountain eroded, the weight lessened, and some of the things that were 50 miles under the earth came to the surface today, where we have kind of flat. And that's where St. Cloud's granite comes from. Originally some 50 miles underground, raised to the surface. To the south, there's what's called the Sioux Quartzite Band, and this extended into Wisconsin and Michigan, and so there's a Baraboo Quartzite and a variety of other evidences of the eroded Pokian Mountains that could still be found. I said that plates can move together, they can also move apart. And 1.1 billion years ago, there was a plume of sorts of magma that rose up from the guts of the earth and seemed to bulge out under what is now Lake Superior. And so originally there was a bit of a bulge, and then the plate started moving apart and created a major rift valley. Today there's a major rift valley in Africa, but basically we had a big rift in Minnesota that stretched from Kansas through Iowa, through Minneapolis, up to Lake Superior, then curved down to Michigan and into Ohio, where the earth separated. Some 60,000 feet of magma solidified and is discoverable under Lake Superior as a result of this event. Had not some other event intervened, we would be seashore here in Minneapolis. The other event is believed to be a collision from the other side of the tectonic plate that sealed off that force of the collision. 3 events I mentioned, one more interesting one. A mere 250 million years ago, recent history. Nothing. Minnesota was south of the equator. At that point in time, the equator ran through what is now North and South Dakota. Now, how could that be? Well, it was, in fact, that the plate that we were on was here, and since then, it turned 90 degrees counterclockwise over time. Just some interesting ancient geological facts. And I've got intrigued with rocks recently because of my father, but I just wanted to share science. How we take, through the course of human knowledge, we've had hundreds and thousands of people who try to understand why things are the way they are. They've taken the time to not just believe in myth and magic, but to go into the field and to see what's there and learn and understand what and how things are the way they are. And today, you and I can go out into the field and see the evidence of the truth. And I think that we should, in fact, celebrate just the wonders of how science has allowed us to see back 3.5 billion years ago. Mr. Toastmaster.
Thank you, Earl. I'll be asking